Greetings, dear students. Today we are going to see about set theory, basics and applications. I am Dr. Kritika from Sugna College of Arts and Science, Coimbatore. Now we can see introduction to sets, notations and operations. First of all, what is meant by set? In our real life, usually we'll say set of boys, set of girls, bunch of flowers, like that we'll say no. So, set means it is a well-defined collection of distinct objects. In each objects in a set is called elements of set. That means suppose if you take alphabets, English alphabets, totally 26 alphabets we have. In that 5 letters only vowels. So set of vowels means A, E, I, O, U. That 5 letters we can write in a curly bracket. So inside of the curly bracket we can represent the set. Set of even numbers less than 10, that is also set, means 2, 4, 6, 8. So less than 10 no. So even numbers 2, 4, 6, 8. These are the examples for set. We can represent set with capital letters, capital letter alphabets A, B, C, D. Elements we can use the inside of the curly brackets, and then the common notation. Actually, we have two representation of a sets. One is rooster form and another one is tabular form. Tabular form means suppose we have to write a set of even numbers less than 10. Less than 10, so less than 12. So 2, 4, 6, 8, 10. These are the even numbers we can represent inside of the curly bracket. So this is called tabular form. The same thing we can represent in set builder form. So the set A is a set of even numbers between 1 to 10. How to represent this in a set builder form? X is a element from numbers, and X such that X is a even numbers between 1 to 10. That means how to represent this set builder form into tabular form? What is the answer for this? Even numbers between 1 to 10. What are all that? 2, 4, 6, 8. These 4 numbers are the answer for this set builder form into tabular form. Now types of sets. Types of sets. Many types we have. Finite set, infinite set, empty set, equal set, subset. Many sets we have. Empty set means the set has no elements. That means inside of the curly bracket we don't have any elements. Then that set is called empty set. Finite set means if we can count. If we can count the elements in a set means that set is called finite set. Uncountable, the elements inside of the set is called uncountable, then that set is called infinite set. For example, for a finite set 1, 2, etc. 10, this is finite set. But infinite set means 1, 2, etc. it's going on, so then that set is called infinite set. Equal sets, if two sets are exactly with the same elements. Suppose the set A is A having 1, 1, 2, 3, 4. B having the elements 2, 1, 3, 1, 4. Here these two sets having same elements. So these two sets are called equal sets. Subset. Every element of A is also in B, then that set is called subset. See, suppose A having elements 1, 2, 3 up to 10. 1, 2 up to 10. B having the elements 1 to etc. till 15. Then here 1 to 10 is also inside of B. So A is the smallest set, B is the biggest set. Then A contained in B. That means A is a subset of B. So here A contained in B. We can say this notation as subset notation or contained in. A contained in B, then this B is called superset, A is called subset. A contained in B but not equal to B means that set is called proper subset. A is contained in B equal to B, then that set is called improper set. So these are all the types of sets. Now we can see Venn diagram. We can represent the sets in Venn diagram also. This Venn diagram is nothing but the visual representation of sets and their relationships. So we can represent this Venn diagram using circles and overlapping areas represent intersections. See here, this is the set A. This is the set B. A is having the elements 1, 2, B is having the elements 1, 2 till 5. So here we can represent the sets in Venn diagram. So this rectangle represents the universal set. Universal set means it is a biggest set. Inside of the universal set, we can represent this universal set as U. Inside of the universal set, we have two sets A and B. Here, suppose A is having the elements 1, 2, 3. B is having the elements 1, 3, 5, 6. So A having 3 elements 1, 2, 3 and B having the elements 4 elements 1, 3, 5 and 6. Here A and B having common elements. What are all the common elements? 1 and 3. Here also we have 1 and 3. B also we have 1 and 3. This common part we can represent here. This is the common part of A and B. So we can represent this as A intersection B. Intersection means intersection represents the common elements of A and B. Union represents the elements in A or B. So we can represent this A union B in Venn diagram. This is A, this is B. A union B, how to represent this A union B? A elements in A or B. So the element should belongs to A or B. Then this shaded part is A union B. Here this is A, this is B, this central part, this is the common part, this represents A intersection B. That means inside of this common part A intersection B means the element should belongs to A and B. The element should belongs to A and B, then that is represented with the symbol intersection. This symbol is called intersection. This symbol is called union. Now complement of a set. See here, this is the universal set. Suppose this is the set A. This is the universal set. Complement of A means other than A in the universal set. That means this shaded part, other than A, except A. This shaded part is A complement. We can represent this with the notation A power 1. That means A dash. This is called complement of a set. See some of the Venn diagrams we have given here. Here in this first diagram we can represent the shaded yellow color part as A only. In the second diagram this yellow color part is only B. Here in this diagram except A, the remaining we have shaded. That means the remaining part, the yellow part is what? Complement of A. Here except B, the remaining part shaded, so except B, therefore this is complement of B, this one. Here A union B represented with yellow color, that means this full part A or B. Here this shaded part, this is a common part, so this represent with the symbol intersection, A intersection B. See, now we can see another diagrams, another Venn diagram. This also like the same thing in a different color we have represented here. See how we can represent, we can use this Venn diagram in a problem. For example, how to find, see here the set A having 1, 2, 3, 4, B having 1, 2, 5, 6, 7. What is the answer for A union B? A union B means the element should belongs to A or B. So we can combine this. See, one thing we have to notice here, the repeated elements we don't want to write once again. Single time we can write inside of the set. So here also we have 1, here also we have 1. So one time we can write, that is enough. 2 also 2 times we have A. In A also we have 2, in B also we have 2. So one time we can write 3, 4, 5, 6, 7. So all these elements belongs to A or B. Then A intersection B. A intersection B. What are all the common elements here in A and B? The common elements are 1, 2, yes, that is enough. 1 and 2 only the common elements in A intersection B. These examples are given here. In the first, this first symbol represent null set. Null set means this empty curly bracket. Inside of the curly bracket we don't have any numbers, any elements. Then that set is called empty set. And then intersection, see here the common elements is 9 and 14 only. Union we can write all the elements inside of A and B. In the set here we have elements in A is 3, 7, 9, 14 and then B having the elements 9, 14, 28. So A contained in B because what are all the elements in A contained in B? The elements 9, 14. 9 and 14 in B also, A also. So A contained in B because 9, 14 is in B also, A also. And then A is a subset means that notation. A is a subset means this notation we can use. This is called contained in. A contained in B. See here, suppose A is having 1, 2, 3, 4. B is having 3, 2, 1, 4. Then A is contained in B and equal also. Therefore, this symbol we can use. It is a subset symbol. Suppose A is having 9, 11, 4. B having the elements 1, 2, 4, 9. So A is subset of B only, but it's not equal because 9, 4 and 11 in B also, but all the elements contained in B, but it's not equal because B having the extra elements 1 and 2. So this set is called proper subset. This set A contained in B but not equal, so this set is called proper subset. Power set means all the subsets of A is called power set. We can represent this power set as 2 power A. See here, suppose A having the elements 1, 2. What is the power set of A? We can represent this as 2 power A. Power set of A is collection of subsets of A. What are all the subsets? Empty set, singleton set 1, singleton set 2, and then 1, 2. See, one thing you have to remind, always subset and the whole set, empty set and the whole set are the subset of the given set. So empty set this is, whole set this is, and then these two. So 2 power A, that means the power set having 4 elements. How can we verify our answer is correct or not? 2 power A having the elements, number of elements in A is 2. Number of elements in power set 2 power A is 4. See, 2 power A, here 2, so 2 power 2 is 4. So the number of elements in power set is, how to calculate number of elements in power set? 2 power the number of elements in A. Here in the set A we have only 2 elements, so 2 power 2, that is 4. 4 elements we have in a power set. See, few important formulas we have in the set theory, that is n of A union B equal to n of A plus n of B minus n of A intersection B. Suppose if this n of A intersection B, A and B are disjoint sets, means we don't have any common elements, therefore A intersection B will be 0, empty set. So if n of A intersection B is empty set, then n of A union B equal to n of A plus n of B. And then n of A difference B plus n of A intersection B equal to n of A. N of B difference A plus n of A intersection B equal to n of B. N of A union B we can represent with intersection and difference, means n of A union B equal to n of A difference B plus n of A intersection B plus n of B difference A. For the 3 sets n of A, B, C, A union B union C, then this formula we can extend it to 3 sets. N of A plus n of B plus n of C plus minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. So now we can see the problems using the formulas, above formulas. The first question is, if the set A equal to 1, 3, 5, 7, 9 and B equal to 1, 2, 3, 4, 5, find A union B and A intersection B. A union B how to find? We can write the elements should be A or in B. So here A having the elements 1, 3, 5, 7, 9, B having the elements 1, 2, 3, 4, 5. Here 1 and 3, 1, 3, 5 are repeated, so we can write only one time. So A union B is 1, 2, 3, 5, 4, 7 and 9. So A union B is this one. A intersection B, it is a set of elements that should be in both in A and B. So A intersection B equal to, what are all the common elements? 1 and 1, 3 and 5. These are all the common elements. So A intersection B is 1, 3, 5. The next question is, in a class of 40 students, 22 play hockey, 26 play basketball and 14 play both. How many students do not play either of the games? So we can take H be the set of students playing hockey, B be the set of students playing basketball. So we have here two sets, H and B. So here what is 40? 40 is total number of students. 22 represents the students play hockey, 26 play basketball and 14 play both. Both means, see here this 22, how to write this 22? N of H. So N of H is how much? 22. N of B is 26. Common elements, that means play both. The number of students play both hockey and basketball is 14. So N of H intersection B is 14. So what we want to find in this, how many students do not play either of the games. So we want to find the students should not play either hockey or basketball. So we want to find, first we can find the number of students play both the games. That means either hockey or basketball. After that, from the total number of students, if we subtract the students play either hockey or basketball, then we can get the answer. So we can use this N of H union B formula. What is that? N of H plus N of B minus N of H intersection B. After that, if we substitute the given values, we can get 34 students playing either hockey or basketball. Next we can subtract this answer from the total number of students, then we can get the students not playing either hockey or basketball. So 40 minus 34 is 6. So totally 6 students not playing either hockey or basketball. Next question is, for sets A, here they have given the set in roster form. X such that X is an integer, 1 less than or equal to X less than or is 6, and B equal to X such that X is an even integer, and 2 less than or equal to X less than or equal to 8. Find the set A difference B. So first of all, we have to write the given set in tabular form. So how to write the first set? In the first set, they have given X is an integer, but the X should be lies between 1 to 6, but it should equal to 1 and 6. So from 1 to 6 we can write. So 1, 2, 3, 4, 5, 6. And B is an even integer. It should be equal to 2 and 8, and it should be lies between 2 and 8. So 2, 4, 6, 8. After that, A difference B we want to find. A difference B. Then A difference B means in this A difference B, B is the second set. That means the element should belongs to A but not in B. So what are all the elements belongs to A but not in B? 1, 3 and 5. So A difference B answer is 1, 3 and 5. The next question is, a survey of 200 people found that 120 read newspaper A, 150 read newspaper B and 90 read both. How many read at least one of the newspapers? So here also we can use the same formula, N of A union B. Here A represents the newspaper A, B represents the number of people read newspaper B. N of A union B equal to N of A plus N of B minus N of A intersection B. We can use the same method.